Welcome to the lecture on ultimate analysis. In the earlier lecture, we have discussed about the proximate analysis. Proximate analysis is the quantitative analysis of coal, and here ultimate analysis is the elemental analysis and is called as qualitative analysis of coal. This analysis requires high degree of skill. The equipments are expensive. The analysis involves the determination of carbon and hydrogen, nitrogen, sulfur and oxygen. Whereas in proximate analysis, we have determined the percentage of moisture, percentage of volatile matter, percentage of ash and percentage of fixed carbon. Now coming to the determination of carbon and hydrogen. So this is the apparatus that is used for determining the percentage of carbon and hydrogen. So here a known sample of coal will be burnt in a combustion apparatus. So here we will be taking the coal sample. So here we will be taking a known weight of coal sample. Let it be some x grams. This will be burnt in presence of pure oxygen. Then the carbon present in the fuel will be converted to carbon dioxide and hydrogen present in the fuel will be converted to water. Now the combustion products will be passed over two bulbs. The two bulbs are calcium chloride and potassium hydroxide containing bulb. Calcium chloride will absorb the H2O formed and potassium hydroxide will absorb the CO2 formed. Later we will determine the weights of calcium chloride. The increase in weight of calcium chloride, increase in weight of calcium chloride bulb will be equal to the amount of H2O formed. Let it be some x grams, and increase in weight of potassium hydroxide bulb will be equal to the amount of CO2 formed. Let it be some y grams. Now I will tell you the determination of percentage of hydrogen and carbon. Coming to the determination of percentage of hydrogen. So here hydrogen present in the fuel will react with oxygen and forms H2O. So 2 grams of hydrogen, 16 grams of oxygen will give rise to 18 grams of water. So now 2 grams of hydrogen produces 18 grams of water. Then how many grams of hydrogen produces x grams of water. This x gram is nothing but what? Increase in weight of the CaCl2 bulb. From this, percentage of hydrogen will be equal to increase in weight of CaCl2 bulb, that is x grams, by weight of coal sample taken. We are denoting as with some capital X grams into 2 by 18 into 100. Why we are saying increase in CaCl2 bulb is nothing but the amount of H2O formed means here the CaCl2 will absorb the water formed and forms CaCl2 7H2O. So the increase in weight of the CaCl2 bulb is nothing but the amount of H2O formed. Next one is determination of percentage of carbon. Carbon present in the fuel reacts with oxygen and forms CO2. 12 grams of carbon, 32 grams of oxygen gives rise to 44 grams of CO2. Next, potassium hydroxide will absorb this CO2 and forms K2CO3 plus H2O. From this, 12 grams of carbon produces 44 grams of CO2. How many grams of carbon produce Y grams of CO2? Here Y grams is nothing but what? Increase in weight of potassium hydroxide bulb. Increase in weight of potassium hydroxide bulb is nothing but the amount of CO2 formed, which we are denoting it as some Y grams of CO2 formed. From this, percentage of carbon will be equal to increase in weight of potassium hydroxide bulb by weight of coal sample taken into 12 by 44 into 100. So increase in potassium hydroxide bulb means nothing but Y grams by weight of coal sample taken X into 12 by 44 into 100. This is how we will be determining the percentage of carbon. Next, significance of carbon and hydrogen. High the percentage of carbon, higher the calorific value. Already we had discussed this about in the calorific value videos. Less percentage of hydrogen, better the quality of coal. Why means hydrogen present in the fuel or in the coal usually exists in combination with oxygen as moisture or water. This on burning forms steam, thereby reduces the calorific value. Why means the calorific value of any fuel depends on the hydrogen which is existing in free state. That's why less percentage of hydrogen, better the quality of coal. Next, determination of nitrogen. Nitrogen is determined by a method called Zaldahl method. The method is called as Zaldahl method. So this is the apparatus which we are using for determining the percentage of nitrogen. So initially we will be taking 1 gram of coal sample. It will be treated with concentrated H2SO4, and to that we will add copper sulfate and potassium sulfate. So here we are taking this mixture. Now this is nothing but 1 gram of coal sample, concentrated H2SO4, copper sulfate and K2SO4. This copper sulfate and K2SO4 will act as catalyst. So this will be heated in a long necked flask called Zaldahl flask. After heating like this, the solution becomes clear. The formation of clear solution indicates that the nitrogen present in this fuel has converted to ammonium sulfate. That means nitrogen plus H2SO4 in presence of the catalyst CuSO4 and K2SO4 gets converted to ammonium sulfate, NH4 twice SO4. Now this ammonium sulfate will be treated with excess of sodium hydroxide. So on treating with excess of sodium hydroxide, it liberates ammonia. The liberated ammonia will be distilled into a standard acid. So ammonium sulfate will be treated with excess of sodium hydroxide, which liberates ammonia. Plus H2O. So now this liberated ammonia will be distilled into a standard acid. Now the amount of unused acid is determined by titrating with standard sodium hydroxide. From this we will be determining the amount of acid that is used for neutralizing ammonia, from which we will be determining the amount of nitrogen present in the coal sample. So we will determine as follows: percentage of nitrogen will be equal to amount of acid used for neutralization into normality of acid by weight of coal sample taken into 14 by 1000 into 100. Now coming to the significance. Nitrogen is the least desired element. It is the least desired element in coal. Nitrogen will not add to the heating value, and moreover, nitrogen present in the fuel may diffuse into the metal during the metallurgical process and make the sample hard. Now coming to the determination of sulfur. A known weight of coal is burnt completely in a bomb calorimeter in a current of oxygen. Then the sulfur present in the coal is oxidized to sulfates. This on treatment with barium chloride forms barium sulfate precipitate. The precipitate is filtered, dried and weighed. So the coal sample containing sulfur will be heated completely in bomb calorimeter in presence of oxygen. As a result, the sulfur present in the coal will convert into sulfates. Now, this on treating with barium chloride, it forms barium sulfate precipitate plus 2Cl minus. Now this precipitate is filtered, dried and weighed. So 32 grams of sulfur forms a precipitate of 233 grams. That means 32 grams of sulfur produces 233 grams of barium sulfate precipitate. Now, how many grams of sulfur produce some x grams of barium sulfate? Here x grams is nothing but the precipitate that is being filtered, dried and weighed. From this, percentage of sulfur will be equal to the amount of barium sulfate precipitate formed, that means nothing but x grams by weight of coal sample taken into 32 by 233 into 100. So using this formula, we can determine the percentage of sulfur present in the fuel. Now coming to the significance. The presence of sulfur in the coal sample is desirable. Why means oxidation of sulfur is an exothermic reaction. That means it increases the calorific value. But so S plus O2 gives rise to SO2 plus heat will be released. Exothermic reaction. But here there is a disadvantage. The sulfur dioxide produced will further undergoes oxidation and forms sulfur trioxide. The sulfur trioxide will react with the water or moisture and forms sulfuric acid. The so formed sulfuric acid is corrosive. Next, determination of oxygen. Oxygen is simply determined by deducting the percentage of carbon, hydrogen, sulfur and nitrogen from 100. Percentage of oxygen is equal to 100 minus percentage of carbon plus hydrogen plus nitrogen plus sulfur. Now coming to the significance. A good quality coal should have less percentage of oxygen. Why means same like hydrogen, oxygen all is available or exists in combination with hydrogen as H2O. This reduces the calorific value. Hence, lesser the percentage of oxygen, better the quality of coal. In the next video, we will practice few problems on proximate analysis and ultimate analysis. Thank you.